now explore one more important part in this HVAC system. That is the topmost part, we can say, this particular topmost part called as air handler, or popularly called as AHU, that is air handling unit. Now, what is this air handling unit, and how this air handling unit work based on the inputs coming from the chiller and boiler section? And this particular air handling unit is connected to this particular air handling unit, in that these two inputs are coming from the chiller and boiler. That's chilled water is coming from the chiller, the hot water is coming from the boiler, and here there are coils, and it is also mentioned some fan, some filters, and there is some inlet air, outside ambient air that is coming into the air handling unit. And you can see that this particular discharge line to the room or to the building's different rooms, it is circulated. So it can be also seen that there is a back line also, there is a exhaust line also. So exhaust line, in this particular diagram, it can be also seen that it is further used for some efficiency improvements. This particular discharge line that is not directly exhausted to the atmosphere, but in some time of the air handling unit, you can see that some of their properties are used for the efficiency improvement. Yes, so that the load can be reduced from the other elements. For example, the load can be reduced from the boilers, so that there is a less requirement from the boiler. If we can use the warm air, that is exhausted air, their heat, if we can possible to exchange for this particular type of air handling unit, inside air handling unit, then obviously the load of the boiler get reduced automatically in one particular season, and in another season the load on the chiller can get reduced. So it is the task of improvement in efficiency by adjusting different things and incorporating different things. So now we will going to highlight this particular air handling unit now in this forthcoming discussion. Now, which are the different components of this air handling unit? So if I want to highlight the major components of this air handling unit are grills. Grills is the first part. Then dampers are the parts, components. Filters, there are coils, fans, there are different sensors, then there is a frost protection, humidity control, then there may be run around coils, there is a mixing return and fresh air unit, there is a heat fill, and some of the air handling unit can also incorporate plate heat exchangers. So you can see how many components are there in a particular air handling unit. If you want to list out that component, I can say there are grills, dampers, filters, there is heating and cooling coils, there is a fan, various sensors, frost protection unit. These things are for any basic air handling unit, and for some modifications in air handling unit, there may be incorporated force protection unit, humidity control unit, as well as this list, bottom side list, maybe run around coils, mixing return and fresh air mechanism, heat wheel, plate heat exchanger. Now, how one by one, now we will trying to explore this particular air handling unit, so that we get the complete understanding of this air handling unit, and we will also parallelly get the understanding of the measurement type of things. What measurements are required in a particular component of the air handling unit. So you can see this particular diagram is a air handling unit. So there are two different air handling units. You can see one particular air handling unit is actually the supply side, yes, and one is the return side or exhaust side. So upper one is actually the exhaust side, side unit, and this is for the supply side unit. It can be clearly seen from this particular diagram that there are different zones. So one by one, now we will try to explore these zones. You can see there are different zones. Yes, so these are the zones in a particular air handling unit, and in the exhaust, the zones are in a less numbers. You can see 2 to 3 only zones are there in the exhaust side or return side. This is the supply side. The supply side means that the external ambient air gets supplied, and the return side is that from the building the air is get exhausted to the atmosphere, or sometimes directly get exhausted to the atmosphere, and sometimes some amount of that air can be used to recirculate. So now let us see one by one to explore with this. So you can see this particular section, these colors are actually the air handling units. So they can be mounted either in the roofs of a building, sometimes they can be mounted on the floors, and sometimes they can be available in the ground section also. So there are various types of air handling unit. It is not that only one air handling unit can play the role for whole building. No, it is not like that. There are many air handling units available in a particular building. So this particular, in this picture, there are 3 air handling units. One can be on the roof, and one can be on the you can see in the floors, and another can be on the basement or ground parking part over there. And there is a circulation system from this particular air handling unit. So this is a simple first type of air handling unit. You can see what I have shown you earlier. There are various subsections. So mainly there are 2 parts of air handling unit. One part is for the supply. One part provides the supply to the whole building. Yes, and another part is actually the return part from the building. So it can be, you can see that at the beginning of this particular supply part, the external atmospheric ambient air can be taken in, and you can see that this is the conditioned air supplied to the building. The processing will be taken in between this particular supply, this particular unit over here, and then that particular air gets supplied to the building. That is air condition, that is supplied to the building, and the used return air from the building is taken by this particular second section of this air handling unit, that is the return section, and it get exhausted to the, or it get discharged to the atmosphere. So this is very simple diagram you can see for this particular air handler unit. They take the fresh air from the atmosphere. Some of the return air can be recirculated also. Okay, so here in this particular, return air cannot be directly shown to used in the recirculation for the improvement in efficiency, but yes, this is basic version. Yes, but in this particular diagram you can see that, you can see in between these 2 section, middle section, the return air, right? Upper part is return part, and this is supply part. The lower part is supply part. In return part, you can see that the air is recirculated. The air is recirculated using pumps and that. Yes, there are pumps and that connected. You can see over here in this particular region I have highlighted, where the return air is recirculated. So let us discuss this one by one, the parts of this air handling unit. So the first and the important part of the air handling unit is grills, right? I have highlighted the parts by this word, grills. So what is this grill actually? You can see the picture of this particular grills. You can see in the top and the exhaust part. This is the we can say that the inlet part in the supply there are grills, and in the outlet of the return part there are grills. So what is the function of this particular grill? In the inlet and outlet of each housing of these 2 units, we have a grill to prevent What is the function? To prevent objects and wildlife from entering into mechanical components inside the HUD, because there are so many internal mechanical components present in air handling unit. So what is the purpose of grill? So purpose of grill is to prevent objects and other wildlife entering type of things entering into the mechanical component inside the air handling unit. Okay, so air handling unit intake that would have sucked in a whole bunch of trash, we can say that. If you see the second picture, there is a bunch of trash. If this particular unit is not there, so what happen? This particular trash will be affecting the mechanical component, and obviously that required to pay the cost in maintenance and other type of damages that happens. So this is the first part of the air handling unit, we call as a grills. It's simply a that will restrict to pass this particular trash to the other sections. So this is the first important part of air handling unit, that is grills. The second important part in air handling unit is dampers. Okay, so you can see the picture of the second part. This second part is in both the lines, in the return line also and in the supply line also. You can see there are dampers. They are mentioned by the words also here, by returning dampers. So you can see these two particular dampers over here also and here also. So what is function of this damper? At the inlet of a fresh air, right? Because inlet of fresh air is for this particular section from this grill that enters into the dampers. Fresh air housing and the discharge of the return air. Right? Now at the discharge of the return air housing, we have some dampers. The dampers are multiple sheets of metal. What actually dampers are made up of? They are made up of multiple sheets of metal which can rotate also. Which can rotate. They can close to prevent air from entering or existing the AHU. So what is the purpose of damper? Damper can prevent the air from entering into the unit AHU, or it can also prevent to escape from the unit. They can open fully to fully allow air or in. There are different controls now in that particular opening and closing. It may be fully open or it can be partially open based on the controls requirements. So there is control mechanism required for this particular dampers, and they can also vary their position. So there are different positions of opening is possible in this particular dampers as per the instrumentation and control point of view. So there is a damper control. So I will show you one more picture. In that the actual dampers are shown. So in this, if you see this there are opening and closing happens over here. So in one particular picture there is a closing, and in this particular left picture there is opening. But this opening and closing is possible by this very important part that is called motorized controller. So this motorized controller is placed over here that plays the role of opening and closing of dampers. So that their position may be open somewhere in between to restrict the amount of air, right, which can enter or exit. One example has the motorized controller which changes the position of the dampers. Yes. So these dampers now we can understand very well. It can restrict the airflow inside or exist from the outside. The another very important component of air handling unit is filter. Yes, filters are also we are much familiar. So after dampers there are filters. So you can see the filters. Yes, there are two types of filters shown over here. Now these first two parts we have already completed. Now the third and fourth, you can see that there are filters. So filters it can be found from the supply part. Okay, in the supply part you can see the filters only. In the return part, in the upper diagram we can see that there are no filters present over there. but in the supply part there are two types of filters we can see. It is mentioned by their name and colors also. After dampers, we will have some filters. These are there to try and catch all the dirt and dust, etc. What is the purpose of filter? They are present over there to catch all the dirts that coming from the atmosphere and all the dust type of thing that is coming from the atmosphere from entering to the AHU. So it will not allow to enter a small amount of dust or dirt into the air handling units or into the building, and also in the building. If we don't have this particular filter, the dust is going to build up inside the ductwork and within the mechanical equipment. So day by day, if the filters are not present, you know what happened. So this particular dirt dust will be going to be built inside of the duct, right? There is a duct portion, complete duct portion that is used for the supplying of this particular cooled air, and within the mechanical components also, because there are so many mechanical components are present, so that will be present over there. It also going to be entered to the building, and there is another type of problem happens, that is breathing of the particular occupants. So breathing can also affect because of this particular dust, so filter plays the role of this particular thing, as well as make the building dirty. Yes, that is also one of the things that is possible. So we want to remove as much as this particular dirt and dust, right? That is possible, and by using the implementation of filter banks and some kind of pressure sensors are mounted there. So it can be seen that across each of the filter bank. So here there is a filter bank, and here there is a filter bank. In across each filter bank, there are pressure sensors. Why that pressure sensors are there? That is also the questions. So simultaneously we are discussing the operation of that particular part and the importance of the measurement. This will measure how the dirty the filters are. So because filters are continuously catching this dirt and dust, so to know that the current current situation of the filters, so how they dirty are, how much they are dirty, so that required to measure with the help of pressure sensors, and particularly that is indication to the engineers, so that it is possible to replace the filters. As the filter pick up dirt, the amount of air that can flow through them is restricted. Obviously, the dirt catching get increased, the amount of air that can flow through that particular filter get restricted, and this cause a pressure drop. So this particular thing will create a pressure drop, and so that pressure drop get measured by the pressure sensor. And there are two types of filters. Mainly, you can see in the third picture, the panel filter and pre-filters. Yes. So here in this particular picture, you can see the back filter also. So in this, these are the different types of filters that catch the these particular pre-filters, means this particular pre-filter part catch the largest dust part, and this back type of filters, you can see over here, back type of filters that catch the smaller dust particles. Yes, this is the filter unit, and the important is pressure measurement. Why pressure measurement? Pressure measurement is to know the conditions of the filter, whether the filters are working properly, so how much dust is present, so by taking the pressure difference. Then we move to the next part of air handling unit, that is coils. So yes, there are coils, and the input to these particular coils are connected from the chiller and boiler. Now you can see the next part of this particular air handling unit. There are two types of coils: cooling coil and heating coil. First is cooling coil, then is heating coil. These are there to cool or to heat the air. Now, what is the purpose of this cooling coil? The purpose of cooling coil is to cool the air, and the purpose of the heating coil is to heat the air, because because the inlet the input from this particular chiller section that we have discussed earlier, that is in terms of water. Now we have to be circulate the air throughout the building, that is in terms of air. The air temperature of the supply is also get measured. You can see that in this particular, the air temperature of the supply is continuously get measured. Now this particular cooling coil and heating coil, their working is based on the measurement of supply air temperature, because this supply air temperature is actually the air temperature that circulated in whole building. So it is very important to measure the intake air temperature as well as the supply air temperature. So how much is intake air temperature? What is required air temperature? So based on that, the cooling rate can be controlled. That is possible to be controlled in this particular thing. So the measured it at the level of the AHU, means that the inside can be get measured. This need to be at the set point temperature to keep the people inside the building comfortable. So how much comfortness requirement, depending on, there is a set point decided, and based on the set point and measurement of inlet, the difference of that get given to the controller, and based on that the flow rate can be adjusted. If the air temperature is below the set point, for example, if the air temperature is below the set point, the heating coil will get added heat to increase the temperature. Right now, if the temperature requirement means, we can say that set point temperature is higher but actual temperature is lower than that, obviously heating coil will plays the role, right? Heating coil will plays the role. So heater will get in picture, and it will add the heat to increase the air temperature, because it is after the coil, cooling coil. The heater is present after the cooling coil and bring it to the set point. If the air is too hot, for example, sometimes what happen, the air may be too hot, then what happen, then the cooling coil will remove the heat to lower the air temperature. So in different types of set point, these two particular coils get work together. These coils are actually the heat exchangers, because they are coming from the chiller. So these coils are actually heat exchangers. Inside the coil is the hot and cold fluid, usually that is flowing from the chiller section. We know that the chilled water or the hot water that is coming from the boiler and chiller section. So obviously we can call that as a refrigerant or the steam. In terms of the heat water, we can call as a steam, or in terms of the cold water, we may be called as a refrigerant. So this particular is the discussion for this particular coils. You can see that there are temperature sensors that plays the important role in this particular two coils. How they plays the role? They measure the supply air temperature. If the supply air temperature is less, then the heater will take the action and increase the temperature. And if sometime the supply temperature is higher than the set point, then the cooling coil get role in cooling the air temperature. The next very important part is actually the fan. Right now, this fan plays the role. Yes, this is the supply fan. You can say this fan is actually contributing to catch this particular air from the atmosphere, and it will actually provide it to the remaining section of the building. This is going to pull the air in from the outside, and then through the dampers it will pass, then it will pass through the filters, then coils, and then this particular fan will push this out to the ductwork, because after this there is a ductwork. You can see over here, this particular section is connected to ductwork. So then it will pull to the whole building, around the building. There are again here, as per the engineering point of view, yes, we require to know what type of fan is over there. There are two possible fans that can be used in this particular unit. There may be older centrifugal fans, type of fans, type of mechanism that can be incorporated in older type of AHUs, and now that is replaced by the electronically computed type of motors, are replaced with the centrifugal type of motors. So to improve the efficiency, energy efficiency, electrical efficiency, so that required to consume less energy, so that electronically commuted type of fan can be recommended. Now we also know that the regulators are nowadays are replaced by electronic regulators, right? So the older regulators are not more. So that is the purpose. Whole purpose is to improve the energy efficiency. And in this particular, yes, there are some sensors required along with this particular fan. And what sensors are that? They are pressure sensors. So why pressure sensors are required along with these particular fans? This will sense if the fan is running or not. So why pressure sensors are connected? The first important purpose of that is whether the fans are running or not. To know that particular thing, pressure sensor are connected. If they are running, then it will create pressure difference, and we can use this to detect the failure in the equipment and warn to the particular control engineer. And these two particular things will create the pressure difference, and this pressure difference will get detected by the pressure DPT type of pressure sensor, so that whether the equipment is failure, or they are working, is not working, properly working, not working, that things are get detected by this particular type of measurement. And you can see one more picture in that, in the duct entry, in this particular entry, you can see there is one more pressure sensor called as static pressure sensor, or we can simply call duct pressure sensor, because that is placed in the duct area. Duct area is actually the area that the lines that actually supplies the cold air to the, or we can say that the required air to the particular building. That is after the fan. Yes, that is after fan. It is connected. What is the purpose of this particular static pressure sensor? These sensors actually read and some of the data. The speed of the fan is controlled. Actually, that measure the static pressure over there, and based on that, it is possible to control the speed of the fan. So how much is the pressure in that particular duct section? Whether the pressure is required pressure. If the pressure is not required pressure, then based on the output of that static pressure sensor, the fan speed is get controlled. Fan speed is get controlled. So that is called as variable speed drive. So with the help of variable speed drive, the fan speed is get controlled in this particular help of static pressure sensor. After static pressure sensor, now there is a part of duct. Yes, this particular you can see from this picture. Now the duct plays the role to supply all the air conditioning type of air in different types of zones in a building. And you can also see that there is a return duct also. So this particular section is actually the duct section, and these two particular sections are supply section that of AHU, air handling unit, and this is the return part of air handling unit. Two separate air handling unit you can see, and this is the duct part in this particular. This goes to different types of zones or rooms in a building, and there is a return part also. Yes, these are the return parts from three different rooms in a particular building. Now this up till now what we have discussed are the simplest. We can say that the air handling units, they are separate to each other. There is no interconnection between them. Now we are moving to the additional things. We can say that some of the additional things are also available present. Modifications are also available in some of the units. So in the picture that you have seen, you can see that after this particular dampers, there is additional part. You can see this additional part. And what is this additional part? This additional part is called as force protection coils. So there are electrically force protection coils are mounted between dampers and actual coils, that is heating, cooling and heating coil. So before cooling and heating coil, there is one more section added. This section is required in some particular areas only, that is called force protection coils. So yes, you can see this particular thing. This is second thing. Okay, let us have discussion on this particular. If we are living in cold part of the country, right now, if this particular building automation is implemented in some cold part of country, right now, or cold part of the state or city, uh, in that what happened? Air temperature reach at the freezing point, so their temperature is very less in that particular zone, so that is at freezing point or close to it, right now. So in this particular situation, there is a need of free heater. There is a need of free heater in the inlet of the fresh air intake. What happens? The temperature of that particular zone is already very less, that is in the freezing point or close to that. So obviously there is a requirement of free heaters in the inlet of that particular fresh air intake. This is usually any electric type of heater. When the outside air get around, for example, if we take one example of freezing 6 degrees Celsius, if the outside air is 6 degrees Celsius, or in Fahrenheit, if we can say 42.8 degree Fahrenheit, the heater will turn on automatically. This particular heater will get turned on automatically and heat up the air to protect the component inside the this particular air handling unit from the frost. Right? There may be chances of component damaging due to the frost. So yes, obviously this now coil get this particular additional free heater get the plays the role of warming that particular air to a higher temperature, so that the internal component get protected from the frost. Otherwise, what happen? This could freeze the heating and cooling coil. Obviously, now if this part is not there, so this will directly enters into the cooling and this heating coil, and this get freeze, right? And there is damaging of the internal tubes of these particular coils, so that get burst. So this is important part in you also need to be know very well, that is frost protection coil. There another sometimes you can see after this two types of coils. Yes, there is additional part you can see over here. Yes, this is the additional part before the fan. Before the fan is humidifier. So this humidifier is mainly incorporated in some situations to control the humidity and moisture. So you can see at the discharge line, at the supply line, right now. So in the duct entries, there's a humidity sensor that is placed over there. So what is the purpose of this particular humidifier? Now I am going to clarify you. Some of the buildings need to control the humidity of the air that they supply to the building. Sometimes what happens, it is very essential to control the humidity of the air that is coming from the atmosphere. So actually we have not measured the humidity before this particular simple section, but sometimes it is very important to measure their humidity. So that can be possible by humidity sensor connected at the outlet of the supply unit of this AHU, and that measures the moisture in the air supply, right? This humidity sensors measure the moisture in the air supply. This will also have the set point. Some set point is decided, so how much should be the moisture present in the air. Based on the set point, now this gives signal to the control, and then that particular humidity control will be taken place. So now how it can be taken place? So that decides how much will be the requirement of the moisture in the year. If the air moisture content is below the set point, for example, if we consider if the air moisture content is are the below the set point, if some set point is there, if that moisture contents are below the set point, then what happens? Then obviously we will introduce the moisture into the air. Yes, so it is essential in that case to introduce the moisture in the air. And who will introduce that moisture? Then that humidifier will introduce the moisture, because the moisture controls moistures. When that humidity sensor measures the moisture, their values are less as per according to the set point. So obviously humidifier will introduce the moisture into the air. This is actually verified by the humidity sensor later on. How this moisture will get introduced? This can be introduced either by adding the steam or spraying the water mist. Yes, so there are two types of things. Based on the set point, there may be addition of steam, there may be spray of water mist. That can be possible. You can see over here by these pictures, there is a spray of water mist into the air if the air is too humid. Sometimes what happens, air may be too humid, so that in that time there is a requirement of water mist, spray of water mist. Then this can be reduced to the cooling coil. Then this can be linked with the cooling coil, right? So this particular section is interlinked with the cooling coil also. So there is much more details about this humidifier is also there. This actually the moisture within the air to condense and flow away, you will find a drain pan under the cooling coil. So in this cooling coil there is a drain pan. So that drain pan can be used for the exhausting the water contents to the away from that particular coil. So to get that, to catch the water and that drains this particular water away from the cooling coil, there is a drain pan also available with this particular unit. The cooling coil can be used to further reduce the moisture content by removing the more heat, but of course this will decrease the air temperature below the supply set point. So now if the cooling coil plays the role with humidifier, obviously the supply air temperature get reduced. And then again there is a role of heating coil. The heating coil comes in picture, and then it will warm up the air to bring the temperature to their set point. So set point is attached with the humidifier as well as cooling and heater coils to maintain the proper moisture. Now there is another type of additional things that may be available in some of the air handling unit, and that is mainly the part of energy recovery system. So how the energy get recovery from this run around coils? Now we will get the benefit of this run around coil. That is one of the important component in some of the air handling unit. The main benefit is energy recovery of this particular type of things. You can see how it is possible. So run around coils, they are there. So you can see over here these particular sections, they are the run around coils. They are additional coils. You can see this is our cold coil, this is our heating coil, and after that there are these additional things are mounted. They are called as run around coil. If the supply and extract AHUs are located in different areas, then a common way to recover some of the thermal energy is to use run around coil. So if this particular supply side and return side, if they are located in different areas of the building, then obviously what happens? Then the recovery of some of the thermal energy is taken from this particular discharge line or return line. So obviously the load on the heater get reduced. The load on the heater get reduced because of this additional run around coil. This uses a coil in both AHUs, and there is a pump that circulate water between the two. You can see that there is a circulation taken place over here. Yes, this particular circulation taken place over here. So in this particular line, there is a warm type of air gets circulated, and in this particular there is a cold type of air get circulated. This will pick up the waste heat from the extract AHU. This is extract AHU. This will pick up the waste heat, because this heat will get exhaust to the atmosphere. But there are different types of laws and terms and that rules, so that we cannot directly exhaust the warm air to directly to the atmosphere, so that this particular run around coil plays the role. And add this to the supply. This particular heat get add to the supply of the AHU, means supply side of the AHU. This will reduce the heating demand on the heating coil when the outside air temperature is below the supply set point. If the outside air temperature, if the outside this outside air temperature is below the supply set point, then what happens? The temperature, so air temperature will get increased with the help of this return air. The air temperature will get improved because of the return air, with the help of return air. The heat will otherwise be wasted. There is no use of that. So simply it will be rejected to, or it is discharged to the atmosphere. So the pumps are also associated with this, so that the efficiency of that pumps are also required to be the requirement of the efficiency, or the electrical power required for this particular pumps are also ready to be discussed in this particular type of unit. Then the next very important part of this air handling unit is return and fresh air mixing. Return and fresh air mixing. You can see one additional sections now incorporated here. You can see in the return and supply, mixing can be take place with the help of this. So by looking to this particular diagram, you can see that there is a damper, and this is a damper type of picture. You can see that is actually additional part incorporated in the supply and return section. So what we say, some of the air get returned and mixed with the air supply. So this is another type of air handling units. So there are two types of air handling unit. One type of air handling unit where the return air is not used. The return air is not used, means 100% atmospheric air is used in the some of the air handling unit, and another category of air handling unit in that some percentage of return air can be utilized. Some percentage of return air can be utilized. This is the another category of air handling unit, and that is with the help of dampers. That is with the help of dampers. So we know that what is dampers. There is a position control in the damper. So damper get opened, and some of the outlet air, or what we can say, the return air get added into the fresh air. But one problem that may occurs in adding these particular dampers or mixing air is carbon dioxide present in the return air. If the carbon dioxide present in that return air, their levels are above the set point, then that particular air cannot be mixed in a inlet air. If the carbon dioxide levels are below the set points, then and then that returned air can be used in the mixing with the inlet air. So as an instrumentation point of view, yes, it is very essential in this particular to measure the carbon dioxide. So to monitor the carbon dioxide. So this particular carbon CO2 sensors are plays the very important role in this particular section of return air and fresh air mixture. Okay, so we can also use this particular type of arrangement in these two seasons. How we can use in these two seasons? For example, winter season and summer season. Okay, for example, if we use this particular arrangement in winter, if the return air is warmer, right? If the return air is warmer than the outside air, obviously we can utilize this because outside air is colder, right? Not warmer, and the return air is warmer. So in winter season, we can use this particular warm air to get heated the to improve the heat in the air supply. So yes, in summer season, obviously another type of thing. In summer, if the return air is cooler, for example, in summer season, for example, the return air is cooler, then yes, we can utilize that particular return air to mix with the supply air. So all these things are controlled properly by measuring the temperature sensors. So there are different temperature sensors required to handle this particular type of task. So you can understand this particular type of operation by instrumentation view. Yes, how we can do this? By measuring the temperatures by different temperature sensors connected in the intake, in the exhaust line, or in the mixing line. Now we are near to the concluding part, close to the concluding part. Yes. Now, yes, time is also yes, time is also over there. So can I use 2-3 minutes more? 2-3 minutes? Yes. Can I use 2-3 minutes?
Yes, sir.
Okay. So you can see that there is a thermal wheel also. In one of the another type of models, there are thermal wheels. You can see incorporated here, thermal wheels. They are not much popular, but you should need to know that what is complete AHU. So that I have added all these things. Yes, the things get more and more there, but once you get the complete idea of AHU, so it will be very easy to you to understand the things and to apply the control part over there. So our aim is to understand the things in very detail, so that I will not exclude anything from this particular section. So thermal wheels are there. So what is purpose of this thermal wheel? You can see that the thermal wheels are arranged in half portion of the inlet side and half portion of the outlet side. They are exactly arranged in between that. So what happened? Uh, this is very common in newer compact AHU. Some of the compact air handling unit, this particular section is there. This uses large rotating wheel. Okay, this is rotating wheel. Half of this wheel is sit within the exhaust air stream, and half of this is sitting with the fresh air intake. The wheel will rotate, and that is driven by small induction motor. There is a small induction motor control over there. So with the help of that, the wheel get driven. As it rotates, it pick up the unwanted heat from the exhaust stream, right? It will pick up the unwanted heat from the exhaust stream, and and that can be absorbed into the wheel's material. So here there are different types of material used in a wheel that get absorbed that heat. The wheel then rotate into the fresh air. This particular hot part will now move to the cold part, and the fresh air intake that particular stream, right now this fresh air will get intake that particular stream. This air is at the lower temperature than the exhaust stream, so the heat will get transferred from the wheel and into the fresh air stream. So that heat get transferred with the help of this wheel unit also. So this is also the additional unit used for the heat transfer. Now I will have the last part of this particular air handling unit is plate heat exchanger. So some of the air handling unit that wheel is not used, thermal wheel, but that is replaced by plate heat exchangers. So such type of plate heat exchangers are incorporated in between that too. So we know the role of heat exchanger. So that can be used for the exchange of the heat. So plate heat exchangers are used sometimes to do this particular